I've been telling people for some time now that Didgets can be significantly faster than conventional databases. Early ad hoc tests showed that Didgets was often twice or 3 times as fast. Now please bear in mind that in the database world, claims like this are huge. If something new is twice as fast as Postgres, MySQL, or SQL Server instead of a mere 10%, the industry should stand up and take notice. Companies like Oracle or Microsoft and open source projects like Postgres has spent decades fine-tuning their products for maximum speed. And I've recently made several changes to Didgets that have improved its efficiency, and I wanted to get some concrete numbers for comparison and put together this video to highlight my findings. Now I'll be comparing Didgets to Postgres only in this video. As you can see, it's not the latest version of Postgres. I'm using version 9.5 and I'm using pgadmin 3 to do the comparisons. So later versions may offer some speed improvements, but I haven't downloaded and tried those yet. Now I went out on the internet and found a random data generator that would give me a table, a CSV file basically, with random names and addresses and cities and states and all that kind of information. So I imported a 5 million row table into both Postgres and Didgets, so I can do a side-by-side comparison between the two. Now, as you'll see in Postgres, I've got my table here. I've created a number of indexes against them, and I'll get to that in a minute. But let's show you first how we do things in Didgets. So here's our table of names and addresses and a set of queries that I've created against those. Here in my friends folder, I've got another 250,000 row 6 column table that I can just import. It takes a few seconds to import all 250,000 rows, and when that's done, I'll have this nice little 250,000 row table. If I just double click on it, it doesn't select all. There's all the information. Well, I did that with a 5 million row table as well. And as you can see, I've got a set of queries. Some of them are simple, like just find everybody that's in an A state that has South in its address. Zip codes less than 10,000. The name starts with A or B. I've got some with a regex expression, so I want to find all the cities that start with a vowel, A, E, I, O, or U. This is addresses that end in an ST period for streets. So I can run these queries. I can gauge how long it takes for each one to do, and then compare them with the same data in Postgres. So for example, let's run the A or B names. So that returns 705,937 rows where the name started with either a B or an A. Now I can copy that SQL to the clipboard. I've got the monitor performance here so I can tell how long that took. So if I come down here to the end, you can see it took, quickly add that up, 163 milliseconds to run that query. So we go back over to Postgres, and I'll use the explain analyze function here, paste this in, and run it. So in this particular case, it took a little over 1.5 seconds, so 1,633 milliseconds to do that same query. I ran similar type stuff against all 10 queries, and this is what I came up with as results. So for example, the first query, Didgets took 64 milliseconds, Postgres took almost 5 seconds, so we were 75 times faster when the state started with the letter M. For this particular query, we were 8 times faster, so a little under 1 second for Didgets, 6.5 seconds for Postgres. The only query out of the 10 that we were slower was this one here, where we're taking all the emails that have a .gov in them, or end in .gov, and we ordered them by address ascendingly and limited it to 250,000 rows. Didgets took a little more than 14 seconds, and Postgres took slightly less than 13. All the other ones, we were significantly faster. Some we were only 3 times as fast. Others we were 35 times faster, 8 times faster, or 75 times faster. So if we come back and let's look at another one. So these are all the B names that were in a B city, and the country started with letter B as well. So we double click that. Sure enough, we get 1,809 particular rows out of this. We look at the markers, and it took 613 milliseconds, so a little more than half a second. We copy that SQL to the clipboard, go back to Postgres, and run that. So instead of half a second, it took more than a second. So we're more than twice as fast in this particular instance. And again, this is using an index. So we had to, come in and created an index against the names and the cities and the countries, and it still took more than twice as long to do the same query under Postgres as it did under Didgets. Now, there's indexes are not for the faint of heart. So, for example, some of the things we had was because in Postgres, if you do an I like, so I want to find all the state or cities that start with a particular letter or something like that. Even if I have an index on it, if it's not right type of index, it can slow things down. It'll have to do a table scan instead of doing the indexes. So the name is an index that I created on here, and you'll see I used the gin indexes so I can do I like queries against this thing. So let's go back and do one that's just with the names. So A or B names, again, that one took under hours 164 milliseconds, and under Postgres it took a second and a half. So we're 10 times faster, almost 9 times faster. Again, and this one used that bitmap scan, but even though you created an index, you took the time to do that, we're still much faster in Didgets. Now again, I didn't have to take any extra steps to create an index. We don't have indexes in Didgets, so there's nothing to maintain, there's nothing to clean up, there's no performance penalty when I'm updating data within this table because there's not a separate copy of the indexes. It is just our unique way of storing information in the key value type storage. So we're columnar store, we can tell you the information very fast. So for example, we can do some analytics. We've got 705,000 rows where the name starts with A or B, and I want to see all the different cities and how many rows out of those 705,000 values. I just click on the city and say show me the values, and there were 1,428 rows in this table where Jackson was the city and the name started with A or B, and tell you for all the values, all 1,046 different city names, how many rows for each one there were. So we created this so that we could make it really easy to do queries, to do analytics, and make things very fast. Thank you very much.